This speck of light you see, Ascendance, is not a star. It is an entire galaxy, and some of this light has traveled for more than 13 billion years to reach us. In 2021, we launched a telescope designed to capture exactly this light, to look further back in time than anything ever built. The James Webb Space Telescope. It was meant to confirm the story we already believed about how the universe began. Instead, almost immediately, it found something wrong. Something that, by our own rules, should not exist. To understand what Webb saw, you first have to understand what it was doing. Light takes time to travel. When you look at something a billion light years away, you are not seeing it as it is now. You are seeing it as it was a billion years ago. So if you build a telescope powerful enough and point it at a tiny, dark, empty-looking patch of sky, and simply wait, the faintest, oldest light in all of existence slowly begins to appear. Webb is not just a telescope, it is a time machine. And it can see almost all the way back to the beginning. For decades, our model of the early universe told a clear and confident story. After the Big Bang, there was only darkness and a thin fog of gas. Slowly, over hundreds of millions of years, gravity pulled that gas into the first tiny clumps. The first galaxies were supposed to be small, faint, messy, and disorganized. Little seeds that would need billions of years to grow into the grand, structured galaxies we see around us today. That was the prediction. Small and dim in the early universe. That is what Webb was built to confirm. And that is not what it found. When Webb, massive, already full of stars, existing was only a few 100 million years old. A cosmic newborn. Some of them appeared to hold as many stars as our entire Milky Way, assembled in a fraction of the time our models said was possible. Astronomers looked at the data and then looked again, because it simply did not make sense. These galaxies were too big, and they were far too soon. They began calling them the impossible early galaxies. One of them shone from a time less than 300 million years after the universe began. It was far brighter and far larger than anything had any right to be at that age. It was as if you walked into a nursery, expecting to find newborns, and instead found fully grown adults already standing there. The numbers were so extreme that some scientists said, out loud, that if these measurements held, they might break the standard model of cosmology itself, and that is not a small thing to say. The standard model of cosmology is one of the most successful theories in all of science. It describes the birth and growth of the entire universe with breathtaking precision. It predicts the faint leftover glow of the Big Bang. It predicts how galaxies cluster across billions of light years. For it to be wrong about how fast the very first galaxies formed would mean something fundamental was missing from our understanding of everything. So astronomers did what good scientists always do. They tried as hard as they possibly could to prove themselves wrong, and slowly, part of the puzzle began to soften. As they studied these galaxies more closely, they realized that some of them were not made of starlight alone. Deep in their centers, monstrous black holes were feeding on gas and glowing with tremendous energy. And that glow was making the galaxies look far bigger and far more massive than they truly were. In 2026, new research confirmed it. Some of those impossible galaxies were never as massive as we had first believed. And for a moment, the shock seemed to fade. But in its place, a new mystery appeared. Those glowing centers, scattered across the early universe, showed up as strange, tiny, deep red points of light. Astronomers nicknamed them the little red dots. They appear to be some of the earliest giant black holes that have ever existed. Already enormous, already feeding, when the universe was still impossibly young. And that raises a question just as hard as the first one. How did black holes this big grow this fast, this early, in a universe that had barely begun. And here is the part that still keeps astronomers awake at night. Even after accounting for the black holes, even after correcting the numbers, the early universe is still too crowded. Webb's data shows roughly twice as many massive galaxies as our best model predicts. And it keeps finding more. Recently, it spotted a vast spiral galaxy, fully formed, 5 times the mass of the Milky Way, with a delicate spiral structure that, by our rules, should never have survived so early in time. The universe, it seems, grew up far faster than we ever thought was possible. So what does it all mean? No one is certain yet. It may be that stars formed far more efficiently in the early universe than we ever imagined. It may be that galaxies and black holes grew up together, feeding one another in ways we do not yet understand. Or it may be, as some quietly suspect, that there is a missing piece in our model of the cosmos, a new ingredient, a new kind of physics hiding in the first few 100 million years of time. This is what the frontier of science actually looks like. Not a neat, finished answer, but a telescope built to confirm what we already knew, that instead handed us a deeper and far stranger question. The early universe was not the quiet, empty, slow-growing place we expected. It was alive, building galaxies and black holes and vast structure at a speed that simply should not have been possible. And we still do not fully understand how. And Webb's discoveries do not stand alone. They arrive at the very same moment as other deep cracks in our understanding. A universe that is expanding faster than our mathematics allows. 95% of everything made of matter and energy that we cannot see. It is beginning to feel less like a series of small, separate puzzles, and more like a single, quiet message from the cosmos. That our picture of reality, as beautiful and successful as it is, may still be missing something enormous. Webb is still out there, 1,000,000 miles from Earth, staring silently into the dark. Every few months, it looks a little further back in time and finds something new that doesn't quite fit. And each discovery is not a failure of science, but its greatest strength. The willingness to look at the universe, to see that it disagrees with us, and to follow it anyway. Wherever it leads, the galaxies that shouldn't exist, the black holes that grew too fast, a universe that assembled itself faster than the rules allow. Webb was built to answer these questions. Instead, it has only deepened them. And somewhere in that data, in light that left its source before the Earth was even born, the next great discovery is already waiting. If you want to keep looking into the dark with us, subscribe. The universe is stranger than our models, and we are only beginning to see how strange.